Hello viewers, in this topic I am going to explain about the laminar flow through the circular tubes. So the topics I am going to cover in this session is to understand the fundamentals of fluid flow in circular tubes. So to differentiate the laminar and turbulent flow regimes and how we are applying the Hagen Poiseuille equation in the practical problems, and to determine the Reynolds number for the given type of flow, and how it is used in the real world problems. So now the fundamentals, if you are taking, so if a fluid flow through a circular tubes under pressure head, and the velocity will be varies across the pipe section, and also the fluid behavior will be depending upon the fluid properties and also condition. For an example, it will be depending upon the viscosity and density, etc. And there will not be no slip at the pipe walls. Okay, and the always the velocity will be maximum at the center of the pipe. So now if I am taking this the variation in the velocity, so this is a circular pipe. So here this picture shows the energy variation. So here, as I told already, the energy will be maximum, the velocity is maximum at the center of the pipeline, and it will goes on reducing, but at the pipe wall it will be zero. So due to the shear stress which is occurred near the pipe surface, and also due to the friction, this velocity will be getting reduced. So this is the velocity variation. Okay, so this is for laminar flow. If it is the flow is turbulent, the velocity variation will be like this. Okay, so here the velocity variation is entirely different for laminar flow and the turbulent flow, and also this is depending upon the Reynolds number also. If I am taking this for the turbulent flow characteristics, the flow is the laminar, the flow lines will be like this, and it is a turbulent, there will be the formation of eddies will be there. Okay, so and there will be the random mixing of water, and therefore the formation of eddies will be occur, and therefore this velocity profile will not be the uniform, and whenever the Reynolds number is more than 4000, we are calling that as the turbulent flow. So there will be the more high energy dissipation will be there. So if I am taking that the laminar flow, this the laminar flow, the always the Reynolds number is less than 2000 to 2300, and this the thing will be parabolic profile, and there will be the low mixing between the layers, and therefore the flow of water will be very smooth and it will be well defined path. So there we can it is a predictable for taking the flow behavior. So if I am taking for the turbulent flow, in this case the Reynolds number will be more than the 4000. So there will be the blunted velocity profile will be there. So as we have seen in a previous slide, and there will be the high mixing and there will be the formation of eddies, and there will be irregular motion will be there, and also it is very difficult to predict the flow pattern. So here if I am taking the Reynolds number we can calculate by the formula, that is a rho BD divided by mu. So rho is the density of the fluid, and the V is the average velocity, and D is the diameter of the given pipe, and mu is the dynamic viscosity. Okay, so here wherever we are going for some chemical engineering or civil engineering, so everywhere we are using this concepts. Okay, and if you are taking this the laminar flow, so it is used in the microfluidic acids as devices and medical equipments and chemical analysis and systems and fluid transport systems in small tubes. Everywhere we are using. And if you are taking the turbulent flow system, it is mainly used in the oil and gas pipelines. Okay, the civil engineer we are going to use in the oil and gas refineries also, where we will use these concepts. Okay, and also it is used in the aircraft and the aerodynamics industries also. Okay, and it is used in the industrial mixing process. That is for an example, we are using the chemical industries. So therefore if you are taking that the recap of this is we have studied the what is a laminar flow and what is a turbulent flow. So how we can predict by using the formula, and what is the formula for finding the whether the flow is a laminar flow and turbulent flow, and the formula we are using is mainly Hagen-Poiseuille equation, or for finding the Reynolds number using the formula as rho v divided by mu, and the applications everywhere in the civil industry and chemical industry, aptaf industry, everywhere we are using this concepts. Okay, so the main thing we have understood is in a circular pipe how this the fluid flow is occur. So thank you.